Hey everyone, it's Monday morning, November 7th. This is going to be a bit of a strange video. I'm on a work trip and can't use my normal recording setup. And the last time I used my laptop, it didn't turn out so well. So we're going to try using the phone, recording the laptop, and we'll see how this goes. So bear with me this week. We're talking about a new storm developing east of the Bahamas. This is subtropical storm Nicole, just named this morning by the National Hurricane Center. You can see the United States off here on the left side. There's Bermuda up here. And this is a large system, both tropical and non-tropical characteristics. It came up out of the Caribbean and it's been entangled with an upper level trough as it's developed. So what we have is really the center of Nicole is in this tiny little area of circulation that is embedded within a larger circulation envelope, kind of elliptically shaped from south to north here. You can see this whole area generally rotating, and you can see some thunderstorm activity near the center, but bands of it extend well off to the east. Some of the strongest winds are actually in this band, well removed from the center, kind of wrapping around the east side and then around the north side, and then a weaker elliptical circulation near the center. So a mix of tropical and non-tropical characteristics makes this a subtropical storm. And the concern going forward this week is that the track of this system, very unusual for November, may actually take it westward toward the Bahamas and Florida, and then potentially other areas of the southeastern United States. And again, unusual for November this late in the season, but still something we got to watch here, and wide-ranging impacts may occur as this nears the coast. Here's the water vapor satellite image, and this is going to show you an area of very dark gray here. There's a very elongated upper level trough that is entangled with Nicole here, and this is again one of the big reasons for the subtropical nature at this point. And you'll see some of the dry air associated with the trough is kind of looping in below your screen and then coming up as a bit of a dry slot near the center of Nicole. And this interaction with this dry air is going to govern or potentially determine how the structure of the storm evolves over the next few days. One of the things that could happen is Nicole could become more compact in nature, perhaps more fully tropical at some point before it reaches Florida. And that's something that the GFS has shown time and again in a lot of its model runs over the last few days. This is the mid-level moisture plot here, so you'll see areas of brown show the dry air in the similar spots as the dark gray was on the satellite loop I just showed you, and the green is the moisture. So you can see Nicole centered right about here, and this elongated area of moisture kind of associated with where that elliptical circulation is right now. As we go forward on the GFS, you'll see that the dry air kind of wraps in, and you'll still see a lot of it on the southeastern side. Some of the moisture gets confined mostly to the north and west side of the circulation. But as the storm nears Florida, it becomes more compact and symmetric, and so we have what looks more tropical-like, more compact, circular, and a more green, more symmetric moisture field as the system nears the Florida Peninsula sometime on Wednesday. And if we look at the upper level flow, we'll kind of see why this happens. This is the current time. Nicole is centered right about here underneath of this upper level trough, which you can see elongated here, and it extends to the northeast, well to the north. So you can see this very long axis of cyclonic turning aloft, and Nicole is right underneath that. If I go forward a few hours, you'll see the red L pop up here showing the surface location of the developing storm. This is in about 36 hours, so I believe this is on Tuesday evening here on the model. And again, this is the winds aloft, and you can see that the upper level trough kind of disintegrates. If I go back again, you'll see that there was an upper level trough here, and it kind of disappears. It weakens in part due to all that convection occurring near Nicole, and it's replaced by essentially ridging. There's a bit of a ridge extending over the Carolinas here, and then easterly flow aloft, much lighter flow and light vertical wind shear. And this is the kind of situation that could allow the storm to gradually become a little bit more symmetric, but there will still be dry air. You can see that the old upper level trough is still sitting over the Bahamas and South Florida and doesn't fully back away for a little while. And then as the storm nears Florida, there's still a little bit of troughing to the southwest here. So there will be dry air, as we saw on the moisture map that I showed you last right here. So you'll see again there's still dry air on the south side here, and that's going to determine really whether we get a structural evolution and transition of Nicole into something that's fully tropical. And the key on the GFS, and the reason it becomes more tropical-like, is because it starts off with a seedling of a tinier circulation, a more compact structure embedded within this larger, looser structure. And you can see that sort of on the satellite imagery right now. You can see a little bit of a more compact circulation right here relative to this much larger envelope of rotation. And what happens on the GFS is this tiny circulation right here becomes the focal point and is able to develop enough of a symmetric moisture envelope around it that it transitions into a fully tropical cyclone. What is that going to mean for the Bahamas and Florida? Well, it could change the impacts right at the landfall point, because tropical cyclones obviously have a compact area of higher winds and potentially higher storm surge near the center. But regardless of whether this occurs, we're going to have a rather large system in totality. If we go ahead and look at the surface wind field on the GFS, you'll see that a smaller compact circulation will develop within this larger envelope, but the constant in all of this is going to be the very strong area of high pressure building to the north of Nicole, which is why this is going to move westward toward Florida, fairly unusual track for this late in the year. And you'll see that gradient between the high pressure and Nicole causes a very strong northeasterly fetch of flow toward the coast, pushing water, ocean water toward the coastline, generating potential for coastal flooding from South Florida all the way up the coastline into the Carolinas. Very large area of strong wind here, rough surf, rip currents, high winds, potential for power outages near the coast, all that kind of impact. And you can see that there is a smaller circulation kind of near the edge of this that develops on the GFS, and Nicole does become more compact in a way. You can see a little bit of a tighter circulation there, but really it's still a pretty large system here with a very large wind field mostly on the north side and the west side of the circulation. So you can see the large area of potential impact that could be coming here, most of the Florida Peninsula and points north in Georgia, South Carolina, and North Carolina. So really quite a large event is coming here, and the reason that there could be some intensification is because the water is still warm, and so we see the GFS showing Nicole strengthening a little bit. Water remains 27, 28 degrees Celsius. Could certainly facilitate some sort of tropical transition, and really the interaction with the dry air associated with the upper level trough that is currently entangled with will determine how strong the winds around Nicole eventually become. This is another example of the HWRF run that just came in this morning, showing the current state of the system, fairly weak and broad, and you'll see a lot of the dry air coming up the east side here. And as I go forward in the HWRF forecast, you'll see again dry air kind of wrapping in on the south side as it interacts with that upper level trough. But as I continue going forward, you'll see that your screen will gradually become more and more green as the system nears the Bahamas and the Florida Peninsula, and you'll see that there's a much more symmetric circulation here by the time it is east of West Palm Beach there on this forecast. This would be around Wednesday evening, 8 p.m. Eastern Time. You can see a more symmetric, compact structure, again, more tropical-like. So we are seeing some evidence in the modeling that this could happen, but the details are rather murky right now, and we're just not sure exactly how far along in this transition process Nicole will be by the time it reaches landfall. You can see it attains this more circular structure right before moving into the Florida Peninsula. And then from there will be additional details to figure out, such as whether it crosses the peninsula and moves over into the Gulf of Mexico, and then will likely make some sort of turn toward the north. I'll just show you the upper level flow again. You know, we have a ridge over the southeast U.S. that is pushing Nicole westward on the GFS, and you'll see it kind of cross the Florida Peninsula into the northeastern Gulf of Mexico here. But then what you'll see is off to the left of your screen here, there's a big trough coming in over the Great Plains. Eventually that's going to kick this out toward the northeast. It can't go west for very long. It's November. There's a strong jet to the north, and so you'll see that as this comes sweeping in, that ridge clears out, and this would eventually turn back toward the northeast in some fashion. We just don't know the details of that very well yet, but this general idea of some sort of turn toward the north and northeast is likely to happen in some form over the next few days. This is the first official forecast from the National Hurricane Center for subtropical storm Nicole. You'll see that westward track, like I was talking about, generally toward the northern Bahamas, where we have a tropical storm watch in yellow there. And you can see the large area of yellow near the initialization point that shows the current size of the tropical storm force wind field, 40 miles per hour or stronger in that region, and that will spread around mostly to the north and west side of Nicole as it begins to butt up against that ridge over the southeastern U.S. over the next couple of days. You can see that track toward the Florida coastline, currently coming in between West Palm and Port St. Lucie on this particular forecast, but important not to focus on the details of that landfall point right now. There is some uncertainty given that the system is broad and loose, so the exact landfall location might be a little hard to pin down 3 days in advance here. This is, Wednesday night that we're showing a potential landfall in this forecast. And then again, the details of this turn toward the north and northeast, whether it's out over water again, maybe it emerges a second time off of Georgia and South Carolina, or maybe it stays inland. Not really sure yet at this point, but you can see that it kind of stays in this general area for a couple of days at least. Could be a broad area of heavy rain and prolonged coastal flooding given that strong fetch coming down toward the coast, especially on the north side of Nicole. That's going to be the key thing to watch. So a wide range of hazards potentially coming here. And right now, they're not expecting hurricane force winds, but they mentioned that it could be close. We talked about that transition to a fully tropical structure. If that does happen and there's still time left over water, we could see hurricane force winds near the center of Nicole by the time of landfall, but we need to watch the evolution of the storm structure over the next couple of days to see if there's actually a strong likelihood of that happening. There is a chance it stays broad and loose the whole time, which would reduce the maximum winds. That would be good news. But again, even if that happens, and even if we don't get a hurricane out of it, there's still going to be a very large area of elevated gale force winds, well over 40 miles per hour in this whole region, no matter what, that could cause coastal flooding. So do pay heed to your local notices and flood warnings from the National Weather Service. Visit hurricanes.gov for the latest information on Nicole, and I'll do my best to post some updates as we go along here this week. Again, I'm on a work trip and may not be able to produce videos the way I normally do, but we'll see how this turns out. Thanks for bearing with me, everyone. Stay safe.